Hello, 111 students. This is a video that's going to go over part of that even more practice problem that we gave out in the notes on 10/29/18. You can find the answer key at StudyPod, but I'm going to do a step-by-step walkthrough of all of the parts. This is the first part where we're going to balance the chemical equation that we need. So you prepare two solutions in water. The first is made from calcium chloride. The second is from potassium phosphate. When you mix the two solutions, a precipitation reaction occurs. Calcium phosphate precipitates out of solution, while the potassium chloride coproduct remains in solution. We're going to write a balanced chemical equation for this process. So the first step in any chemical balance or equation balancing is to write the formulas and indicators of state for all species. Now we've listed 4, so we're going to write their formulas and we're going to figure out what state they're in. So first off, calcium chloride. Calcium is one of our alkaline earths. It's always going to form +2 cations. Chloride is a halogen. It always forms a -1 ion. So that's going to be CaCl2. And we're preparing a solution of that in water, so it is aqueous. Our next compound is potassium phosphate. Phosphate is one of our polyatomic ions. It is PO4 3-. Potassium is an alkali metal. It will always form a +1 cation, so it will. We need 3 of those to balance out the phosphate charge. K3PO4, and that is also aqueous. Now let's talk about our products. First one, calcium phosphate. Calcium phosphate, calcium will be a +2 ion, and phosphate is a -3 anion. To balance the charges, you need Ca3, and then in parentheses, put PO4 with a 2 outside those parentheses to indicate that there are 2 phosphates involved. And it says that it precipitates out of solution, so it will be a solid. Our other product is potassium chloride. This is KCl. And it says that this remains in solution. Okay. We are going to abandon these indicators of state and bring them back in later. We're going to write our initial equation with reactants on the left and products on the right. So CaCl2 plus K3PO4 is going to become Ca3PO4 plus KCl. Now we can begin balancing. We do that by adding coefficients in front of these different species to try and balance the number of atoms of each element. We're going to treat that PO4 polyatomic ion as if it is a single unit because it's the same on both sides of our arrow. There's just, multiples of them. We're going to try and start with an atom that appears only once on each side. In this case, I'm going to start with this calcium. So we have 1 calcium in our reactants. We have 3 in our products, so a very easy way to try to start balancing it is to put a 3 in front of our CaCl2. So 3 CaCl2 plus K3PO4 becomes Ca3PO4 2 plus KCl. All right. Next, let's try balancing our chlorines since we've affected their balance by adding this coefficient. We have 6 chlorines on our reactant side and only 1 on our product side. So let's put a 6 in front of that KCl. 3 CaCl2 plus K3PO4 becomes Ca3PO4 2 plus 6 KCl. Well, now that we've played around with that, we've messed with our potassium. So it's a good idea to try and balance our potassium next. We've got 6 potassium in our products. We've only got 3 in our reactants. So let's put a 2 in front of the potassium phosphate to balance them. 3 CaCl2 plus 2 K3PO4 becomes Ca3PO4 2 plus 6 KCl. So we've played around with the potassium phosphate. That means that we now have 2 phosphate ions in our reactants. Let's look at the products. We have 2 here. We've gone and balanced each of these, so it's time for us to do an idiot check to see if we've gotten the right number of everything on each side. Let's begin with our calcium. On the reactant side, we have 1, 2, 3. On the product, 1, 2, 3. So 3 and 3, this is balanced. Chlorine, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, also balanced. Potassium, 6 and 6, this is balanced. And our phosphate, PO4 3-, we've got 2 in our reactants and 2 in our products. So these are all balanced. One more step, we're going to check that all of our coefficients are as small as possible. So 3, 2, 1, 6. This has a 1 in front of it. We know that this is as reduced as it can possibly be. So now we can write our final equation and include our indicators of state. So we've got 3 CaCl2 aqueous plus 2 K3 PO4 aqueous becomes 1 calcium 3 PO4 2 solid plus 6 KCl aqueous. So there's our balanced equation for this process. Check out the next video for what we're going to do with it.